Hey, B here. I've just been hanging out outside, enjoying some fresh air, and I noticed something interesting. I was standing next to this tree, and my shadow and the tree's shadow were both stretched out on the ground at the same angle. I measured the shadows and found that mine was 6 feet long, and the tree's shadow was 15 feet long. I know I'm 5.5 feet tall, and all this measuring made me start to get curious. Could I use these shadows and my height to figure out how much taller the tree is than me? And even how tall the tree is overall? Hmm. I realized that my shadow and I, and the tree and its shadow, make a pair of similar triangles. Okay, maybe we're onto something here. Before we figure this out, let's take a look at some other examples and practice using what we know about similarity in solving equations to find missing values.
So, here we have some triangles, and hey, what's this? It's called a similarity statement, which tells us that two triangles are similar. The squiggly line in the middle means is similar to, and the triangles are named by their vertices or corners. So, this statement says triangle HJK is similar to triangle LMN. In addition to telling us when two triangles are similar, similarity statements help us identify corresponding angles and sides. This is extra helpful when the triangles have different orientations or the corresponding sides aren't as obvious visually. How do you think we can use a similarity statement to identify corresponding angles and sides? It's all about the order of the vertices in each triangle's name. In this example, angle H corresponds with angle L because they're both the first angles listed in the triangle name. Side JK, the side between angles J and K, corresponds with side MN. Pause here and list the two other corresponding angles and two corresponding sides using the similarity statement. Check your work. Remember, the key to similarity statements is the order of the letters in each triangle's name. Now, let's find the measurement of angle N. How can we use what we know about similar triangles to do that? Well, we know that corresponding angles of similar triangles are congruent, so we can set them equal to each other. What angle corresponds with angle N? Yup, angle K. What's different about these angle measurements compared to the ones we've seen before? Yeah, the value of each angle is represented by an expression, not just a variable. Angle N is 4x degrees, and angle K is x plus 31.5 degrees. So, in order to find the value of angle N, we first need to find the value of x. Setting up an equation with the values of angles k and n gives us x plus 31.5 equals 4x. We'll subtract x on both sides to give us 31.5 equals 3x. Then divide both sides by 3, giving us 10.5 equals x. So, angle N measures 10.5 degrees? Not quite. That's just the value of x. To find the value of the angle, we need to substitute 10.5 into 4x and evaluate. 4 times 10.5 is 42, so angle N measures 42 degrees.
What about missing side lengths? Here we have two similar triangles, triangle BRG and triangle ZET. We're being asked to find the value of n and the length of side BG. When we calculate side lengths in similar triangles, what do we need to do first? That's right, calculate this scale factor. Let's use the similarity statement to help us identify all the corresponding sides. In the smaller triangle, we have sides BR, RG, and BG. Pause while you identify and name the corresponding sides in the larger triangle.
Let's see here. Side BR corresponds with side ZE, since they both use the first two letters in each triangle's name from the similarity statement. Side RG corresponds with side ET, and side BG corresponds with side ZT. Which sides can we use to calculate this scale factor? That would be BR and ZE, or RG and ET. Because of the variable, we can't use sides BG and ZT. We wouldn't be able to simplify the fraction or evaluate the division. If we label the figure with the variable as the image, we'll get 4 over 20 or 5 over 25 as our scale factor, which both simplify to 1/5 or 0.2. Next, to solve for n and find the length of side BG, we'll come back to our trusty equation for relating a pre-image to a similar image. Pre-image times scale factor equals image. 35 is the pre-image side, our scale factor is 0.2, and n minus 11 is the image side. That gives us the equation 35 times 0.2 equals n minus 11. Go ahead and solve for n, and then substitute the value of n back into the expression n minus 11 to find the length of BG. Solving the equation gives us 18 equals n, and 18 minus 11 is 7, so side BG is 7 units long. Here's our next example. Triangle LTM is similar to triangle VSR. Find the value of h and the length of side TM. Which side corresponds with side TM in the smaller triangle? That would be side SR, since the letters are in the same position in the similarity statement. Before we get started on finding the scale factor, let's label our image and our pre-image. So far, we've been making the figure with the variable the image, but both sides have a variable here. In cases like this, I'll usually choose for the image to be the triangle with the expression that uses more operations. But here, both sides, TM and SR, use 2 operations. So let's just make the bigger triangle our image and the smaller triangle our pre-image. If you're feeling confident and ready to try on your own, please do. Or you can follow along with me. The only pair of sides that doesn't include a variable is LT and VS. So, now that we've labeled our image and pre-image, the ratio for our scale factor is 40 over 20, or 2. When we put the values into their positions in our equation, we have the quantity 3.5h plus 2, all times 2, equals 6h plus 8. We'll distribute to simplify the left side, get our variables together on the same side, and solve for h using inverse operations. H equals 4. Are we done here? Nope. We have to substitute the value of h back into the expression 6h plus 8 to find the length of side TM. 6 times 4 is 24, and 24 plus 8 is 32. Woo! That was a lot of steps, but we used all sorts of skills we already had in our back pockets to figure it out. Before we move on, take a moment to pause and explain the steps we used in this example in your guided notes.
I think we're ready to solve my original problem. Here's all the information again. How much taller than me is the tree, and how tall is it overall? Pause while you work.
Using the bigger triangle with the variable as the image and the smaller triangle as the pre-image, our scale factor is 15 over 6, or 2.5. Our equation will be 5.5 times 2.5 equals 5.5 plus x. Here's the work for solving that equation. 8.25 equals x. We substitute 8.25 into the expression 5.5 plus x to get 13.75. Since I'm 5.5 feet tall, that means the tree is 8.25 feet taller than me and 13.75 feet tall overall.
Great work today using your knowledge about similar triangles, scale factor, and solving equations. Finish up your guided notes before heading to the online practice for today. And remember, math is everywhere. Keep exploring.
Hey!